Good morning, AP Calculus AB class. Today is Wednesday, March 25th, and I have some requested homework problems to work out for you from section 5.8, page 386. One that was requested was number 43, and that is to find the derivative of the inverse trig function, and that is given as g of x is equal to 3 times the arc cosine of x over 2. So if you recall our formulas from yesterday, which are here, the derivative of the arc cosine, but we have an x over 2 as our function within the arc cosine, so we'll do the derivative of the arc cosine of f of x, which will be negative 1 over the square root of 1 minus the function squared times the derivative of the inside function. All right, so here we go. So the 3 is a coefficient, pull it aside. We have the negative from our formula, and then we get 1 over the square root of 1 minus the function x over 2 squared times the derivative of x over 2, which really represents 1/2 x, so the derivative is just 1/2. And then the rest of this is just simplifying it. So here's my negative 3 in my numerator. My 1/2, the 2 ends up in the denominator, and 1 times 1 is 1, times the negative 3, which is negative 3. And then I square the x over 2, and I get x squared over 4. I get a common denominator for the 1 as 4/4. Then I combine the 4 minus x squared all over the common denominator of 4. So I have 4 minus x squared over 4, which I break into the square root of the numerator over the square root of the denominator. So I have the square root of 4 minus x squared over the square root of 4. The square root of 4 is 2, which then cancels out this 2 I have also in the denominator, and I end up with negative 3 over the square root of 4 minus x squared. Hope that helped for number 43. All right, also requested was number 45. F of x is the arctangent of x over a. So again, we look at our derivative formula that we have for the arctangent of the function, and that would be, the derivative would be 1 over 1 plus the function squared times the derivative of the function. All right, so we've got 1 over 1 plus the function, which is x over a squared, times the derivative of x over a, which x over a is really 1 over a numerical coefficient for x. So the derivative of 1 over a times x is just 1 over a. So now all I do is simplify this. What do I do in the next step? I square the x over a, so I get x squared over a squared. Then I get a common denominator of a squared for my 1 and my x squared over a squared. So I have a squared over a squared plus x squared over a squared. That's this here. Everything else is still the same. Then I combine my numerators, a squared plus x squared all over a squared. And that's still times 1 over a. And 1 over this fraction just flips the fraction, gives us the reciprocal, which is a squared over a squared plus x squared times our 1 over a. And this a cancels one of those, and our answer is a over a squared plus x squared. Okay, hope that helped. Now, I didn't have a request for number 42, but I know that's not in the back of your book, so I just wanted to post the answer here. F prime of t is equal to 2t over the square root of 1 minus t to the 4th power. Hope you all got that one. All right, I don't have a long lesson. I just want to point out that if we have derivatives, if we have derivatives of the inverse trig functions, that means we can integrate them and get the inverse trig functions back if we integrate these derivatives. So these, I'm just going to focus on these here. So if we look at the integral of the square root of 1 minus x squared dx, we can see if we integrate that, we get arcsine of x plus c back. If we integrate negative 1 over the square root of 1 minus x squared dx, we get arc cosine, because the derivative of arc cosine is the negative of 1 over the square root of 1 minus x squared. And of course, we put out the plus c in there. And if we integrate 1 over 1 plus x squared, which is here, and was the derivative of arctan, we get arctan of x plus c. Now, I just want to show you what would happen if you tried to do one of these with a u/du substitution. So let's say you took 1 over 1 plus x squared, and you said, oh, I'm going to do this with u/du substitution. I'll let u be 1 plus x squared. But then when I take the derivative of u, I get du equals 2x dx. Well, we could compensate for the 2, but we can't compensate for the x. There is no x in this numerator. So we can't adjust for this 2x dx missing from this problem. So this technique does not work with this problem. And then we think, oh, now I remember, that's the derivative of the arctan. So the integral of 1 over 1 plus x squared is arctan x plus c. Or we could write it as tangent to the negative 1, meaning arctan of x plus c. So how does that compare to if we could have used a substitution? The problem would have to look more like this. 2x over 1 plus x squared. Then our u would be 1 plus x squared. Our du is 2x dx. And we end up integrating 1 over u du, which we've done before. Natural log absolute value of u plus c. And then I don't need the absolute values because 1 plus x squared is always positive. So I get ln of the quantity 1 plus x squared plus c. But I just wanted to compare them because sometimes this inverse trig function shows up on the AP test. And if you try to do this as a u/du substitution, it's not going to work. And that's because the antiderivative is really the arctan. And also because there's no 2x dx in this problem. All right, I hope that helped. And I just wanted to show you that for today. I don't have an assignment specific to this because I'm sending you to youtube.com. If you haven't already found these videos that I mentioned yesterday in my group message, AP Calculus AB is doing some videos. I think they're about 45 minutes each on today, Wednesday, Thursday, and Friday. They are live at 11 a.m. each day. But after that, then they become available as recorded. So you can find them at youtube.com, or if you use the links I gave you the other day, you should be able to work through those and find the videos. If you go to youtube.com advanced placement, you scroll down to AP Calculus AB, you'll see there's one for tomorrow. I think it's on differential equations. I will be watching them. I just want you to watch all 3 of them by the end of the week. And then we can talk about, and note if you have any questions or anything that happened in the videos that you didn't understand, and I will explain that to you. We can plan that for Monday, but you can send me any questions prior to Monday on any of these videos that you watch, and I'll address them on Monday. Okay, I still will want you to check in every day, and I guess that's where we go, because this is the assignment for the rest of the week. Okay. All right, hope you have a great day and have fun watching the videos.